Hi, folks. Thanks for being in class today. I want you to make sure you have your notebooks out so we can go over all of this information right now. First off, I want to talk about the notes from the results from the quiz. When I looked through the Canvas quiz, the biggest questions I think people had was, what does it look like when it's positive correlation, negative, no correlation, and constant correlation? And there was one problem on the quiz that I felt was somewhat difficult to see. But just remember, when you're doing positive correlation, the values and the dots specifically mostly are going up. Not everyone's going to be on that line. And that same goes when you're predicting from the line. One of the questions asked you something about a prediction and it said 16 or 14. And remember, if the lines are going or the dots are going up, I wouldn't want to predict a number that's lower than that value because that doesn't follow the trend. So just wanted to point that out. Likewise, a negative correlation are values that are mostly going down. And this is what a constant correlation was. That was an answer on one of the tests or on one of the quiz questions. And I don't know if you knew what that looked like. And lastly, this right here is something where, and also an A, that there is no correlation. So just wanted to make sure you're clear on that. Feel free to take a picture of this with your phone and go from there. So let's go on to our notes for today. And what we're going to do is we're going to talk about variables and slope and in the intercept with those variables. It's going to be extremely important that you put this in your notes. You will not be able to do the work from the for the homework tonight. So I hope that this is in here. First off, we're going to talk about this right here. This is an absence and final exam scores. And remember, the first thing we talked about last time was making sure we have checked our conditions and whether or not something is a linear situation. And first off, we are checking our conditions, making sure that it's quantitative, it actually makes a line, and that we can go from there. So this one has check conditions. We're going to look and we can put in a line. We'll talk more about the best way to find that line, but remember back to Algebra 1-2 when we actually kind of just draw it with the ruler and hopefully it goes through the most ones. And then we're going to find the correlation. Okay, these are points on our line. So remember, we're talking about number of absences and the grade on the final exam. This is our equation right here. It's y equals 91.704 minus 1.654x. And when we want to talk about that, we want to kind of think about what do those numbers mean. So I'm going to keep referring back to this equation and situation, and we're going to put this information in our notes. Also, it's important that we know that r is negative 0.93. And that should make sense because this is a mostly linear situation. Also, it should make sense that it's a negative because our points are going down towards the negative. Okay, so let's interpret this and talk about what these values mean. First off, you need to make sure that you have this in your notes, that x is the explanatory or independent variable. Please remember this word explanatory. It's in red for a reason. And the reason is because our textbooks sometimes use that. It's explaining what's going on. It's the one element that explains changes in y. So here, x is the number of absences. And that x right there is the explanatory or independent variable. And that should make sense, right? Because ideally, the final exam score should correlate with the number of absences that you have. Next, write down this. Y is the response or the dependent variable. It's the things that responds to changes in x. So even looking at this specific situation here, as your absences increase, your final exam grade is going down. Okay, make sure you have this, and we can stop the video real quick here to make sure everybody has this written down. Okay, good. Hopefully everybody has this written down. Now let's talk about the slope and the intercept, okay? Making sure we know what this equation is. And remember, this is that standard y equals mx plus b equation that we have from Algebra 1-2. We're still using it. So remember that b is our starting value. That's the score when X is equal to 0, no absences. So our interpretation is you get a 91 if you have no absences. And that's great score right there. So remember that that is my B value. When I put in X for 1, this arrow is talking about it. Or excuse me, when I put in 0 for X, that's what I'm going to get. 91.704, which is the score you would get. And that's our B. Now M is our slope, and there we go. You can see with our arrows now. And that's the amount the score increases when X is increasing by 1. So let's think about that. We know that slope is the change in Y over the change in X. So what this is saying is that since we know X stands for our absences, for every one absence, our score is dropping by 1.65 points. And it is perfectly okay for you right here to write next to this change in Y over change in X. And then I would go a step further. Next to change in Y, I would write final exam score over absences. That way I can interpret that even more and say, okay, that number means for every 1.65, our score is dropping for every one absence, 1.65 points. Take a moment and make sure you have this written down, and we'll pause it. Okay, so you can just do these on your own up here. You don't have to work with the person next to you, but I want you to see if you can analyze with a linear regression line. Here is my scatter plot. Can you analyze? And this is just an example right here. Okay, so I want you to take a moment looking at these situations right here and see, can you come up with the R value? So take a moment and then we'll write down what they are. We'll pause the video. Okay, what are they? I hope you got that R was 1, or at least 0.999 repeating. I hope for number 2, you got somewhere between a moderate negative relationship. And folks, if you don't have this in your notes, make sure you do. We wrote it down last class, and we said we added the negative ones on the side. But that's a pretty moderate relationship for a line there. And I hope for the last one, you've got somewhere between 0.8 and 1. And again, I don't expect these to be exactly correct. You're just guessing these. You don't have the knowledge. But at least you're kind of seeing what it looks like for it to be a very strong, the first one, a moderately negative relationship, and another very strong one. Let's pause the video here and see if you can come up with these answers. Okay, let's look at this right here. Again, this is a strong negative one. This one's not looking too hot. It's moderate, but it's pretty close to weak there. And this one is even more. I would say this looks somewhat the same, but there are more dots on here than there are here. And that's really what we're looking at for the determination between a moderate and weak relationship. Okay, let's try one more slide of these. Pause the video. This is just no relationship. There's just 2, and I know it looks like there's more on here, but there's so many outliers. So that's also something we have to consider, that there's just too many outliers. And this one, do you see how those, like up here on the top one, the outlier is pretty strong, and down here, whereas here it's just not as much. So this one is a strong relationship. Okay. So right now what you're going to do is we're going to stop this video and you're going to do the following thing. You're going to grab a Chromebook and you're going to complete 3 problems on each of the links found on the calendar. I'll show you in just a moment. You're going to turn your answers in the basket at front, and when you're finished, you're going to grab the homework / classwork. And then the second thing you're going to do is you're going to work on completing the mouseless lab, and you're going to go into the computer lab to do that. Okay? So right now I'd like you to do that for me, and then we will go from there. Thank you very much, and I will see you next class.